All right. So now I'd like to talk about something called, called object-oriented programming. Has anyone heard this phrase before?
Yes.
All right. Do you want to take a stab at defining it?
Oh, that part of it. So it's just everything kind of revolves around the idea of these objects that they give you like a general structure that you can reuse over and over, but different like parameters down there that changes. So like the way I kind of like had read about it was like you can describe like a ball as this basic thing of being round shaped, filled with air. But when you add other things, like if you change, actually no, yeah, and then you could change like the color to orange, and then the material to like rubber, and then it's like a basketball. If you change the color to like white, and there's like the size down, like just different things on it. You can change that ball from basketball now to like a soccer ball, for instance. So
yeah,
that's kind of how I.
That's a good example. That's a good explanation. So the general gist of it is that everything in object-oriented program revolves around something called objects, and objects are reusable and they're scalable. So Python is what we call an object-oriented language, meaning that everything in it is a type of object. Everything from strings to integers to arrays to dictionaries, they're all objects. And if you're actually like going to open up this, the Python editor, if I say, a equals string. If I wanted to say type of A, it gives me, it's a string class. If I do type of 1, it's an int class. So it's a string object and an integer object. If I can do, type of that even, it's a list. So talking about objects, an object is, it's essentially a type of data structure, like an array or a dictionary, anything like that. But the difference is that an object can hold attributes and can hold behaviors. So I like to think of an object as like a noun. Like the example that you used was ball. So a ball has attributes, like it could have diameter, could have material, could have color, and it could have behaviors, bounce, roll. I don't know what else balls can do. But that's the general idea, is that Python and several other coding languages, everything is a type of object, a type of object. And objects are defined by their classes. So think of a class as like a set of instructions or a template. A class is where you define a type of object and everything about those objects. So we could say, class, we can make a class called dog, for example. So this dog class that we've created, it's a new class in Python that hasn't existed until now. And we can even, if I just do this, I could say D equals dog. If I run this let's see. Cool. Python OP. Oops, I need to print it. So we can see its classes __main _dot_dog. So that this double underscores Dunder main is more or less saying that it's a dog object which is found in this file. This is not an built-in Python class, but that is still a dog object. So kind of one thing I want to impress upon you, and if there's one thing I really want you to take away from today, might be it, is there is a big difference between a class and an instance of that class. So I've created the class dog, which right now doesn't do anything. All it is just a class with no behaviors or inbuilt attributes. But the class is just a set of instructions about what dog objects are. This variable D, which equals dog with the parentheses there, this is what's called an instance of that class. So if I can do, so we can make one instance of the class dog, we get another one, Fido is equal to another dog. These are separate things, and also separate from the class as a whole. Like how in strings, if we write down a string, that is a member of the string class. It is a string instance, but it is not string with a capital S. Any questions about the difference between those? And we're gonna, see more a little bit that'll illustrate what the differences are and what the things like that. But classes and instances.
Hey Noah, are
Yes.
instances stored within classes, or are they stored kind of outside of them?
Good question. So, by default, a class, its job is not to keep track of every instance that it's created. Like the Python string class doesn't keep track of every string you've made. The class just gives instructions on how to build that object, essentially. But it doesn't keep track of all of them. There are ways to make it do that, but generally speaking, it doesn't do that by default. Was I? Oh yeah. Do people want to kill the lights? I just realized.
Oh, just a little bit.
Okay. So while I'm here, so classes in Python, by the way, so convention is that they are always capitalized. Oops, how'd that happen? So if you see something called class, dog, class, anything with a capital letter, that means it's a class. All right. So right now we can make a dog object, but the dog object doesn't really have anything to it. It's just dog. So we're going to give our class some attributes. So what are some things that all dogs have in common?
Legs.
They have legs. How many legs do they have?
Sometimes 4, but sometimes 3.
Usually 4. And they got eyes, usually 2 eyes. Tail equals 1. So 4 eyes, 4 legs, 2 eyes, 1 tail. And I'm gonna make and fur. I'm not sure.
True.
Yeah, fur equals true. Yeah. All right, and we're gonna give this this dog a method. Let's call it, display features. So this is what's called an instance method. This is a method that belongs to it, that an instance of a dog class can call on. Whenever you make a method inside a class, it always takes self as an argument, every time. So let's see. First I'm just going to, so if I do f string, so I'm going to say dogs have self.legs, legs, self.eyes, eyes, and self.tail, tail. I'm not going to say and true fur because I'm not sure if that really scans, but all right. So if I do that, I'm going to actually just have Fido, and I'm going to say Fido.display features. So if I run my code, dogs have 4 eyes, 2 eyes, and 1 comma tail. Whoops. There we go. All right, so I've used that self attribute a few times now. Now, self is an important concept in object-oriented programming in particular, and essentially without self, Python wouldn't know where to, what class to find these attributes from. And we can actually even check what self is by doing print self. So this is what I get when I print what self is. Get out of here. Thank you. So we get a main.dog object at 0x1048675550. Anyone have any idea of what this is?
Protection.
Yes. So someone said it's essentially a representation of this object's location in memory. So if I make another dog, call him Roscoe equals another dog, and we do Roscoe.displayFeatures. What the heck? I don't know how that happened. What the heck? I'm in the wrong. How did I get here? That was weird. I do not know how that happened. One sec. Okay. So I've gotten 2 dog objects with different IDs. So these IDs show us that these are different instances of the dog class that are stored in different places in memory. So yeah, if I took out self dot in all of these places, let's see what happens. So I've heard one person say it might break. Yep. Legs is not defined. It doesn't know where to find these variables without self. Self is an argument saying, hey, hey dog, you instance of the dog class, check yourself, find how many legs you have, how many eyes you have, and stuff like that.
That's just a shortcut. If you wrote dog dot legs dot eyes dot, is that
like that?
Yeah.
Let's find out.
Okay.
Yeah. So in this case,
So self itself doesn't inherently mean anything.
I mean, what self means depends on context. And this goes ahead a little bit of where I was going to be, but that's okay. Because the way we've defined these variables here, because we've defined them just right after we declared the class, these are what's called class variables. So these variables belong to the dog class as a whole, which is why we can say dog.legs. In this case, this dog, like each dog has access to these variables because they belong to the class as a whole, not to an individual dog instance. That's why we can say dog.legs. But there will probably be instances where we want to make sure that each dog is initialized with its own information. Because not every dog will have the same name, for example, right? So to do that, we need to have a function that'll allow us to set attributes that are specific to this dog. To do that, we're going to use one of those Dunder methods I've been talking about. Yep, Dunder init. Dunder. So usually when we see those Dunder methods, what we're saying is we're taking an existing method. Init is essentially what happens when we call this, like dog._init is actually the same thing as just saying dog. And we're saying, okay, we're going to be hijacking that new method, the method that creates a new dog, and we're going to be adding some features to it. So let's say I want to initialize a dog with a name. What else do I want to initialize a dog with? Color, maybe breed. So now when we create a new dog, it takes arguments. And in order to set those as instance variables, meaning variables that belong just to this instance of dog, we would do this. Self.name is equal to name. Self.color is equal to color. And self.breed is equal to breed. So when we say self.name, we're saying, okay, this dog's name is this argument that we're giving it. So now if I display, I'll make another method called introduce self. Maybe introduce dog. How about this introduction? There we go. I just didn't want to introduce self and then take self as an argument. That would get confusing. So then I could say self.name. So now with this one, I would say, I can't just, so if I run it now, missing 3 positional arguments, name, color, and breed. Say Fido is named Fido. Color is brown. Breed is Doberman. And Roscoe, name is Roscoe. Color is blue. Blue Bulldog. All right, because I also need to call on introduction as well. Hi, my name is Fido. I'm a Doberman. My fur is brown. Hi, my name is Roscoe. I'm a Bulldog, and my fur is blue. So in this case, Fido and Roscoe, these separate instances of the dog class, they both have access to all of this stuff, but each one only has access to this. This dog object doesn't know anything about the name, color, or breed of the other dog object. All right. Pause for questions for a bit. Does anyone have questions about how classes have been working up until now? Yes.
What does it mean by positional argument?
Good question. So it takes self by default, and we don't really need to worry about that. These 3 right here, name, color, and breed, whenever we pass them in as arguments, we need to pass them in that order. So if we did, mix them around, said Doberman, Roscoe Brown, it would say, hi, my name is Doberman, I am a brown, and my fur is Roscoe. So positional arguments mean that the position of these arguments is important to what order they're put in. There are alternatives to that. For example, a very effective way to do this, and we'll explore this in more detail another day, is if you pass in a hash, then you don't need to worry about what position anything's in, because then you can just say, give me the key from this hash called name, or a dictionary is what I mean.
Oh.
And actually, I believe, let me try it. I believe we can also do this. I think this works. Let's see if it lets us do this. Yep. And as you can see, we actually got color and breed mixed up. So in this case, the position of the arguments didn't matter, because when you're making an object like this, you are allowed to specify what you're using, which is a cool thing that Python does. Not most other languages I've seen don't do that.
What does init do again?
So init is a function that runs whenever you create a new instance. So for example, I could just say like print creating a new dog. So when I do that, creating a new dog, it runs automatically when we say Fido equals dog. So technically, the init method and most other Dunder methods like this, they're already built into essentially the larger object class that everything belongs to. And and so we're just kind of saying, all right, when you run this init thing, here's some other stuff to do.
Besides dog, what's maybe a more applicable real-world example where a program would be creating several instances?
Good question. I was just about to get to that. So how about we make another program? Let's say we have a program. I'm going to comment out this stuff. We're helping a company keep track of their employees. So I can make a class called employee. And let's say that we have a class variable called number of employees. Starts at equal to 0. And we can have, let's say we also have, there's like a static raise amount that they all get. Let's say raise amount equals, they can get a raise of $1.45 if they're lucky. So these two variables are class variables. They exist across the entire class. Every instance of employee was going to have access to these. Now let's also give it some instance variables, instance attributes. So what information do we want to track about an employee? Yeah, so we have an ID, a name probably. Anything else?
The current
Maybe
salary.
department.
Yeah. Yeah. Department and salary. So we make sure we save so just having these arguments there doesn't mean they'll be saved as variables. We have to actually go self.id equals ID, self.name equals name, self.department equals department, and self.salary, whoops, equals salary. And one thing we can also do is we want to make sure that when we hire a new employee, create a new employee instance, the number of employees should go up, right? So we could do employee.number of employees plus equals 1. So we can add some driver code to this. We can say Noah equals employee, ID number is 1, name is Noah, department is education, salary is $20. Then we can have Rod equals employee 10, Rod administration, oops, yeah, I got a dot, not a comma. And when I do that, I could always say, print Noah.name or Noah.department. Like there. And then I can also check print employee.number of employees. So that should be 2. All right. Any questions so far about how this has worked? Okay, so let's say we have a function as well that says def give raise. And that takes self as an argument. And we wanted to say your salary gets multiplied by the raise amount. So we could say self.salary, salary, times equals employee.raise amount. So I do just print Noah.salary the first time. Then I'll say Noah.give raise because I deserve it. And then print my salary again. I got a raise of $9 an hour. All right.
Wait, I'm sorry, Noah. Was the raise amount defined as 9 at the very top?
No, I just find it as 1.45.
Okay.
So in this case, instead of giving myself a static raise, I gave myself a multiplying raise. So I just said I gave myself a 45% raise, essentially.
Ah, okay. I see.
I could have also done plus.
To the normal professional role.
Of course. All right.
Oh, okay, so it wasn't $1.45, it was 145%.
Yes.
Gotcha. Okay.
So I could have also done.
It would have been $1.45 if you did plus equals instead of times.
Right. That's why I was confused on the math, but now it makes sense.
Yeah. So that was just an example. It's, you can do it any way you want. All right. What are some other behaviors we may want to model for this? For this employee, modeling the employee. Because the kind of ideal of object-oriented programming is you want to model real-life behavior as much as you can. And so eventually you're going to be creating large systems of different classes and different types of objects and modeling how they interact with one another. So we've got this employee class. What else can we do with it?
Maybe like access level for certain databases.
Permissions?
Yeah, permissions. Yeah.
We can add that as an argument here. And then I'm not sure how you write what a permission is.
Yeah, depending on how the system is.
Yeah, we could just be like, have that be a string, level 1. Well, Rod has access level level 10. Something like that. And then we could also have something that says, and now it's a string, we need to be able to say something like, that would involve some string parsing, actually, if we want to raise the access level, because now it's a string. So it'd probably just be easier to say, make that a...
Just a number.
Yeah.
String part could be level.
Yeah. And then we can make a method that says, like, def display access level. Self.permissions. So I do Noah.display access level. I should get level 1. Actually, I wonder, I have an idea, and I'm not sure how well it's going to work. What if I want to be able to fire somebody? So I could say, def fire employee. So how would I want to handle that, do you think?
Employee lines.
Number 1.
Yeah.
Well, yeah, that's the part. First
Yeah.
thing you always want to do is restrict employee access.
Yeah.
Number 1, user permissions.
Level 0.
Yup.
Yep. So we could say, yeah, sort of
Set to.
self.permissions equals 0. And now this is the part that I'm not sure if it'll work. Delete self. I don't know if it'll let me do that. So let's find out what happens if I say, all right, Noah.fire employee. And then if I just want to print out Noah, let's see what happens. Okay, so it's still created, this employee object still exists, it looks like. If I just do print Noah.name after I get fired. Okay, so an object can't delete itself, it looks like. Good to know. But
you'd probably edit the employee class that maybe like an active versus inactive thing on there.
Yeah. And I could, make it self.salary equals 0. And again, like if we want, oh, that's the dog class. Like this isn't standard practice, but if we wanted to keep track of all the employees, we could make one that says, all equals an array, and then add each instance to the array when that happens. That's not really considered good practice, but we could do that. So we could say employee.all.append self. And then we'd remove self from the all array when we do that. I'm not going to do that because, like I said, that's not considered very good practice. I realized I did this very, very quickly. So what other questions do you have about object-oriented programming and classes?
So what was the best way to remove an entry?
Yeah, I don't know if I don't know if you can give an object a method of deleting itself. Because when I tried to do that here, it's like,
Right, yeah.
del self.
I remember.
It didn't,
Right.
it didn't delete it. So, I don't know, maybe this may be a problem that Google can help us with. Like Python.
Not the exact location of where it's at in memory. Can you use that?
possibly Python object deleting itself. So why won't this work?
So blunt.
So let's see what this guy says. So self is only a reference to the object. Del self is deleting the self reference from the local namespace of the kill function instead of the actual object. So it just deletes the variable. So
What was that answer?
So it says you don't need to use del to delete instance in the first place. Once the last reference to an object is gone, the object will be garbage collected. So that's just more of a larger memory problem, but in this case, I don't know if there's a way for a function, for a class instance to remove itself.
So if we just set all the attributes to null, then it would just remove it on its own?
And essentially what it would, what it's actually saying is that once we get past line 56, all of these, all these things in memory just get garbage collected, they're gone. They only exist while the program's running and stop once it's gone. But when we're doing things like databases, then we'll want to worry about persistence and go, okay, we want to make sure that happens. And that'll probably be a problem for when we're working with things like SQL. Because then it's SQL's job, it'll be our object's job to say, hey, I want to make a SQL query to remove myself from the database. But it looks like we can't do that. It looks like deleting self just removes this variable, which is not helpful. Okay, but I can at least set permissions to 0, self-salary to 0, set everything to null just so that this class instance just won't be able to do anything. Oh, sorry, I just saw Ian posted something in Python.
Yeah, I was wondering if that would actually work.
Let's see.
For what we're trying to do.
So init for .count, and then, so yeah, we can delete it. We can delete an instance of a class outside of the class itself. Okay,
but not actually inside of the class.
Yeah, I could do del Noah, and then if I print Noah, it should. Yeah, Noah is not defined because I deleted it. But putting it in, it looks like you can't do it from inside the class itself. Learn something new every day. All right, cool. So again, this actually went a lot quicker than I expected. So
is there a quick way to set all the values to null? You know, like we were just describing that. And so instead of just going through and doing, self.permissions, self.whatever, is there a way to do it for all the different variables you've set?
Probably. So this would be a mass assignment thing. So let's see what happens if we see if there's any mass variable declaration and assignment in Python. Let's see, assign multiple variables at once with dynamic variable names. That sounds cool. So it looks like they have this way of doing this. So let's try it this way with just parentheses equals that. So if I do self.name, self.id, set he just permissions, salary, set everything, ID, name, department. Nope, we want it to be none in this case. Let's see if that works. Okay, so here it says, can I unpack non-iterable none type object? So maybe we have to do none, 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 none. For as many of these as there are. Sure. Try that. There we go.
So it pretty much does the same thing that we did in a less elegant looking way, I guess I would maybe call that.
Yeah, I mean, it's a little less elegant looking, but it is all in one line, so it's...
Was there an answer to that guy's question? Because we were just going off of what he was asking, right?
So,
Or that was the answer.
so he was saying, I know I can do this, which is what we were looking for.
Right.
His question was, how could I make the names of the variables more dynamic? So some
Okay.
function, 1, 2, 3. So it's an interesting problem, but it's not necessarily related to what we're working on right now.
Hey, was this question how to like get everything set to like null or none at the beginning? Or
No.
No, it wasn't.
He was-
assigning to each.
That's
one,
called
two, three.
tuple unpacking. So they're unpacking foo to 1, bar to 2, and
Yeah.
that's as fast to 3.
Yeah. So his question goes a little bit deeper than what we want, but he was displaying what we were looking for in this case, which was, can we just change a bunch of variables all in one line? And the answer is yes, by using a tuple.
So if you created an instance without passing anything in, is there a way to set the default values?
You can set default values the same way you would set anything else.
Okay. Just
So-
put whatever the default is in there.
If I do
Cool.
So in this case, because it's if I pass it as a positional argument and it's not the last one, it won't know which one is supposed to be the name. So it'd have to do it like this, you know. And then if I print Noah.name down here, it's going to get rid of all this other stuff. Oh, non-default argument follows default argument. Okay, so it looks like in Python you have to put a default argument at the end. Let's try to fix that.
Also, self wouldn't just override.
So let's do it this way. There we go.
can you have just multiple like constructor functions, like just another init function? So say if you don't have any information, like the ID department, can't you just have like an empty parameter init function that just sets everything? I don't know.
So if I'm understanding your question correctly, it's what we want to find out is if we wanted to just have default values for everything and we just didn't set anything, like didn't say anything. Is that right?
Yeah. So say if we didn't have the ID department salary, can you just have another init definition that just takes in nothing except self, and then once it's called, it just assigns everything we want down to like a blank.
Yeah.
Can we do it that way too?
Let's see what happens if we define a second init function. Just print something out in this case, just to make sure it works. If it runs, then we'll know we can do stuff with it. So in this case, what happened was it looks like it ran init here, and it got to here, and this one doesn't take any arguments, but we gave it arguments, and it didn't know what to do with them.
So if you were to create an instance without calling the class again, without any parameters, it should work, or no?
We can try. Let's just get rid of this line.
Oh, yeah, this is like-
Oh, well, actually, so it looks like it did create that.
Okay.
Interesting. So we can do that. I don't think that's necessarily the best way to handle something like that, because I think we can just as easily just give everything a default value, and that would give us the same thing of just making sure that we can handle it if we don't get any input. Because generally speaking, defining the same method twice can lead to confusion and breaking stuff. So,
if I'm not mistaken, if this Stack Overflow says that you can't declare multiple constructors, so in that case, your first method might not have run because you already said it the second time with I ran. So
Yeah.
if you run that, it's actually going to fail because is.
Yeah, so if I do, do it traditionally without doing that, making sure everything is set up the way I want it to. Department. I gave it too many things. Nope. Yeah, now if I run it, it's only using the second init, not the first one.
Okay. Yeah, it was just confusing because in Java you can have multiple constructor functions that take like different amounts of parameters. I guess Python is really different.
So Python doesn't support overloading, so you can't define multiple definitions of the same name.
Yeah, not in the same namespace. We're going to talk about something later where you can essentially do that, which is about inheritance. And inheritance means I've got one class that inherits behaviors from another class, and then we can say, all right, I've got two inits, one from this one from the top one, and I want to call on both of them. But in the same namespace, in the same class declaration, you can't overload. It looks like you can't overload an init.
There's only one constructor function per class. Then.
Yep.
For the same reason, you have to name your, for example, each unit test you have to name differently, otherwise they won't run. If you have, for example, three methods in the unit test with the same name, only the last one will run. So that's what I found. That's very interesting. It's very
different than any other. Different than any other language.
Yeah, Java does that.
Yeah. So object-oriented programming is very diverse, very flexible. So there's many different ways things handle things. For example, the first object-oriented language I learned was Ruby. And Ruby, you can't actually access things like your salary or things like that without writing a special method just to do so. Like I couldn't just print Noah.salary. I would have to write a method to display the salary and another one to change the salary. But Python just lets you do it out of the box. So every way does it, but the general philosophy of it is the same, which is we model the behavior we want to see, whether it's an employee, whether it's something that exists in a database. That's often what happens, and then we can model how these classes interact with one another. We mimic their behavior in real life, and also how we want to display it. And that's how it shows on the page. It's not the only programming paradigm out there. It is a very popular one. But kind of a counterpoint to it would be JavaScript. JavaScript is not an object-oriented language, though it can use object-oriented methodology. JavaScript is what's called a functional language, which is quite a bit different. All right. Any other questions about object-oriented programming? All right, raise your hand if you feel like you could define a class and make it do something right now. All right, I saw a few hands not raised. If you have concerns, let me know either now or after we're done. But in that case, I think we are going to stop it here, and so y'all can do your one-on-ones with Rod. Yeah, so I think after this, you'll have one-on-ones with Rod, and then we have some, let's see what our actual projects are for today. Go back to Kilo Platoon. Yeah, so both of these are going to be using object-oriented programming. Yeah, so we got guessing game and Boggle, and also Boggle Part 2. And Rod just posted the.
Ooh, I like calling it stretch.
Yeah. So you'll be using object-oriented programming to model this behavior. So yeah, good luck.